Also, regarding your mocks, this was your first set of mocks. So it was very tough. 5 mocks that this is unfortunate thing about the mock that no one done better or worse than the exam, which what it means. To make it and something that has happened for the last 3-4 years, right? So I'm like, so it's a good gauge of what you can expect. Okay, so a very good gauge. I know you might not take it seriously, but okay, so unfortunately, sounds like I mean, we have to take exam হয় না খারাপও হয় না so that's something but ভালো হয় না so এখানে যদি ভালো করার পর you are guaranteed that you'll do well in that. Okay, so just keep that in mind when you do your mock. So before I return your papers, there's something that you need to try out. Some questions while we start. Right, last class we saw the transport equation I equals to NAQV, this equation here. So এখন যেটা করব is কি টাইপের question আসে এখান থেকে ওগুলো একটু ডিসকাস করব. Okay, and then we will start voltage. আমাদের প্ল্যান হচ্ছে এটার পরে we'll be doing potential difference. There's something called a potential divider. ওই টপিকে যাব, and after that we'll do the Kirchhoff law. And তারপর হচ্ছে there's something called practical circuits. ওইখানে we learn about something called internal resistance. ওইটা হয়ে গেলে electricity is over. So 5 classes হয়ে যাওয়ার কথা. Right. So any questions before I move on? কারো কোনো question থাকলে আমাকে বলতে পারো. Just a quick reminder, what is I equals to NAQV? It's called the transport equation. নামটা জানা দরকার. Transport equation is essentially the equation that helps you find out how current depends on the material, the cross-sectional area, and also the charge out there, and more importantly, the what velocity? Drift velocity. What is drift velocity? Definition? Almost there. Average velocity of charged carriers in a circuit. It could be electrons, it could be ions, right? So average velocity of charged carriers in a circuit. What is N? Charge carrier density, right? What is it? Number of charge free flowing or free charge carriers per unit volume of a material. Okay, so yeah, these are the two definitions out there. So I equals to NAQV. It's kind of self-explained. Don't do the equation that echo, right? What if I increase my N? N barano maneki. I have more charge carriers. More charge carrier means more charge would flow. More charge would flow means more what would flow? Current, right? So N barle I barre. A barle I barre. Cross-sectional area barle, I don't know if you remember from all levels, resistance point. It's imagine like a very narrow pipe, and now you have a very wide pipe. Wouldn't that allow more charges to flow through with more ease, right? So the current barre. Q barle obviously I barbe because charge বেড়ে যাচ্ছে. আর তোমার যদি drift velocity বাড়ে তাহলে তোমার current বাড়বে. Okay, drift velocity কেমনে বাড়তে পারে? If your material has too many obstructions or too few obstructions, right? So materials that are not that dense, right, will have a higher drift velocity because the particles can move around more freely. So anyways, this is it. But then despite all of that, drift velocity value never crosses like a centimeter per second. 1 centimeter per second is a very large drift velocity. Typically it's like a millimeter, less than a millimeter per second. So you estimate a question what's an average drift velocity? 1 centimeter per second, 1 millimeter per second, এরকম range answer. Okay, it's very, very slow, what I'm trying to say. Right, so এখান থেকে আরেকটা question আসে যেটা recently আসছে 2 বার, and I'm glad যে আসে because it's easy marks. And questionটা দেখে তোমাদের. Okay, so questionটা হচ্ছে you have wires that are connected next to each other. তোমাদেরকে যেটা বের করতে হবে drift velocity ratio বের করতে হবে. So and the reason why I appreciate this question showing up is because it's already করে আসছি. Let's see if you guys remember. Can you tell me where have we done ratios of wires of different thickness? In electricity resistivity, yes. ASF কোথায় করছি? Yes. Remember the Young modulus experiments with your material cross section? Young modulus মনে আছে? What was the Young modulus? Measure of stiffness, and it's a ratio of stress to strain. right? Stress by strain. So এখানে মনে ছিল we found যে কতটুকু length extend হবে if I change the parameters and whatnot. Same day এখানে apply হবে, okay? So you have these two wires that are connected in a series to each other, okay? And তোমাদের হচ্ছে they're connected to the same power supply. So এরকম একটা connection. And the cross-sectional area of the first wire here is not provided, rather key provide kora diameter is 3d, and the diameter of this smaller wire is provided to be d. Okay, so duta wire hoche diameter provide kora tomoder, and the length of the wire, this length is L, and this length is 0.75 L. খুব important একটা জিনিস, the two wires are made of the same material. Listen carefully, okay? Two wires are made of the same material. What does that imply? Same resistance. Same resistivity, yes, but in our equation, what would it be same? N, charge carrier density. Charge carrier density is unique to every what? Material. So different material, the charge carrier density থাকে, and it's unique for that material, okay? So when I say that both the wires are made of the same material, I'm implying that both of them have same what? Charge carrier density, okay? So these are charge carrier density same থাকবে, so material N and N হচ্ছে same, and the charge carrier in each of these, এটা বলবেন exam বা তোমাদের clarification ও বলতেছি, I'm using a circuit with metal wires in it. What would be my charge carriers? Electrons, right? So these are electrons. So you need to find out if this is wire A and this is wire B, the ratio of the drift velocity in A by the ratio of the drift velocity in B. So what is the velocity at which the electrons are traveling through A divided by what's the velocity with which electrons are traveling through B? So yeah, that's the question. So yeah, VA by VB try for drift velocity ratio. The next mock end of this month, 27, 28 week focus will be on waves. Okay, so Dr. question to the hoy, 7 of them will be from waves. So think of it as a wave exam, along with some of the other chapters randomly added. No, electricity, but I think it's for sorry. What's the formula or what's the value for charge of an electron? Right, 1.6 into 10 to the power minus 19. Though for this question, because it will be a ratio, right? They might cancel out. आंसर আসলো বলো। One by 12. One by 12. Anyone else? It is an MCQ. If you're wondering, কত mark, 1 mark. Yes, answer. এত টাইম লাগাতে পারছি না, কি আসে বলো? How much? 1 by 12, right? RQ, any other answer? 1 by 12. 1 by 4. Did anyone get 1 by 9? 1 by 9. আচ্ছা দেখতেছি। One by 12. Right, so let's see how to do this. First of all, as I've taught you earlier, what do you need to do? What's the first step? Yeah, find the equation with v as the subject, right? So v equals to I divided by n a q. So this is going to be I of a divided by n of a q of a v of a divided by I of b divided by n of b q of b and v of b. এগুলা এক্সামে করতে হয় না, যেহেতু অ্যান্সার স্ট্রাগল হচ্ছে তার জন্য করা হচ্ছে এটা। ওকে, সো এটা এদিকে আসবে আর এটা কি হয়ে যাবে, reciprocal হয়ে যাবে because it gets divided and whatnot. So this is going to go up there and this is going to stay there, and that's basically the equation, right? এখন হচ্ছে আমাদের সিম্পলিফাই করতে হবে। সো আমাদের এখানে হচ্ছে কি কি ক্যান্সেল আউট হবে ওটা দেখতে হবে, and from what I understand সবকিছু ক্যান্সেল হয়ে যায়। ওকে, দেখো n কি সেম না for both materials, so what happens to n? Cancels out, right? Aren't the charges traveling both of them electrons? So what happens to them? Cancels out, right? And the part that I'll be very disappointed if you guys couldn't figure out, current key same or different? Same, right? So current same hole, current would also cancel out. So eventually, তোমার এখানে হচ্ছে কিসের উপরে, right, v হবে না, my mistake, a হবে। Eventually কিসের উপরে তোমার হচ্ছে অ্যানসারটা ডিপেন্ড করে? Exclusively just a, okay? And তোমরা এখান থেকে দেখতে পারতা v যদি দেখো এখানে I constant, n constant, q constant. What's the relationship between v and a? Inversely proportional, right? So আমার এখন just বের করতে হবে the ratio of a. So va by vb is equal to ab by a, মানে area ratio. Now what's the ratio of the area going to be here? The ratio of diameter is what? 1:3. So what is the ratio of area of B? 1:9, right? So this is going to be B touch, so B হচ্ছে d square, and this is 9d square. D square cancel out with J. So 1/9 is the answer. How did you guys get 12? Which part of the equation did you put L? Because the current doesn't depend on L. How did you incorporate L? Wait, that's volume, right? Acha. তোমরা কি বুঝছো? The other thing that I want you to explain here is 9d square হবে না, sorry, I just wanted to show you the ratio of area. Area যদি d is to 3d হয়, sorry, diameter যদি d is to 3d হয়, area কি হবে? A is to what? 9a, right? Isn't that the ratio of area is to side, right? Square হয়ে যায়. Anyways, the point I want to make here is that drift velocity is independent of what of your wire? Length of your wire. And it's kind of evident. I equals to NA QV এর মধ্যে, right? What is length? Only a length নাই তো, right? So the length doesn't really have a role to play here. So the answer is 1/9. And বলছি that it's an MCQ. And what do you just look here? That V and A are what to each other? Inversely related, right? So that's it. Clear এটা? So you guys, I know 0.75 দেওয়া এখানে you might feel like এটা কোনোভাবে use করা উচিত ছিল, but they'll do that, right? So you should not fall for the trap. Anyways, আমরা এখন হচ্ছে move on করবো. So checklist দেখে নেই. Are we done with all 4 of these? I think so. Yep. So this done. So electric current কিছু করার নেই আমাদের. I equals to anything with a monitor will come back again. There's a place where we need to apply it. Okay. So for the time we'll go past current. আমরা এখন যাবো হচ্ছে potential difference voltage 8 okay. It's a series circuit, so current is changing. You're right, but current is changing. Car. Left, right, down, right. So the same. Okay. So extremely boring if you understood it in your own. Okay. Otherwise, you find this new because they can make a job. They can say which voltage. Okay. So I'll go a little fast through it. potential difference in power. So you need to understand what potential difference is. Voltage equation power okay, so these are all the stuff. Last for number 6. So I'll still go through it. It's this thing. So let's start with the concept of potential difference and voltage and EMF. Okay, so it more would be your contribution here. I mean, okay. So voltage. Can anyone remind me? Because all over the place it's a reminder that I keep. What is voltage? Amount of energy flowing. Charge carrier circuit. Anyone else? Well, what is voltage? Work done the charge carrier while moving through a component. Yeah. Work done per coulomb charge. Okay, what do you say? Oh, I into R. No, that's the formula for voltage. That's Ohm's law. A little different. Okay. Acha. So jara bolcho kache kache, I'll explain what voltage is. So voltage essentially means if you have a circuit like this, right? আমাদের তিনটা টার্ম শিখতে হবে আজকে, মানে ক্লারিফাই করতে হবে। একটা হচ্ছে what is voltage, তারপর হচ্ছে what is potential difference, and what is EMF. এই তিনটা are not same. They just have the same unit. Okay. So first of all, let's try to understand what happens in a circuit. So circuit jeta hoy, you have charges that come out from the battery, right? Our charge guloke push kora hoy, and last class I talked about it. Who pushes them? The plus and minus of the terminals act attract or repel kore, and there's a force applied on them, and the force over distance does what on them? Work, right? So these charges actually carry energy. So যখন ব্যাটারি থেকে বের হয়, they have the maximum amount of energy. They carry the full amount of energy in them. And what happens is they move through the circuit. As they move through the circuit, they are, colliding, bombarding with the positive ions. Do they lose energy when they collide and bombard with the positive ions? Yes, right? But we assume they don't. Remember, we used to assume that the wires have negligible resistance. When negligible resistance assume kora hoche, ki assume kora hoche. They don't lose energy where? In the wires, right? But then they come and end up here, and that's a resistor. And a resistor is designed to take what away from your charge? Energy. It's like a toll. You have to give energy to the resistor in order to move through it. And the higher the resistor, the more what do you provide? Energy you provide. Higher resistance maneta ki. There are too many positive ions out there. So as you try to go through them, wouldn't you bombard more often? What would you lose more? Energy, right? So by the time this charge passes through this resistor, comes out from that side, right? You'll find that the amount of energy in this charge is now less. Kichu use up hoye gelo. Okay? Are you with me so far? Acha. Then what happens is this charge will continue to move through. It comes here. And then it goes through this resistor, right? And by the time it comes out from that resistor, ekheno ki sacrifice hoy? Energy sacrifice hoy. Now, an interesting thing is, if there is no other component in the circuit, right, this charge will have to lose what amount of energy in order to go back to the battery? All of it. So the idea is that whenever a charge goes back to the battery, it has to have what amount of energy left in it? Zero. Okay? Cano. The reason behind that is when it starts from here, it is positive. Let's say another battery in 10 volts, positive 10 volts. The other terminal here is 0 volts. And for you to reach the 0 volt, how much energy should you have to reach there? 0. You can't take energy and reach that point. I'll give you an analogy on this, don't worry. So by the time your charge reaches here, you will have what energy? 0, and the charge is back again. And what does the charge do again? Fill up with energy and start its journey, and it keeps doing that, right? I told last class that it never loses the charge or gains the charge, the circuit. It's the same amount of charge that keeps flowing around. What is just changing in them? The energy. Okay. Now let's try to understand what is EMF, what is voltage, and what is potential difference. Okay. So এখান থেকে যখন বের হয়, the amount of energy this 1 coulomb charge carries is 10 joules. So when you have a battery, right, the amount of energy your charge carries is the same as the battery value. So তোমার battery 9 volts হয়, how much does 1 coulomb charge carry energy? 9 joules. If your battery is 3 volts, right, 1 coulomb charge would carry what energy? 3. So whenever we say what voltage is, right, we're basically referring to 1 coulomb charge যখন circuit তে move করে, how much energy do they carry? Okay, so এটা 10. এখানেও কত হবে if there is no resistance in the wire? 10, কারণ কোনো energy use হয় নাই. And then this is important. এদিক থেকে যখন বের হয়, I find it is 7 joules. So can you tell me how much energy was consumed by the resistor? 3 joules per coulomb, right? That's why we say that the voltage across this resistor is how much? 3 volts. Okay, I'll come to that in a bit. Just dekho. Eta koto hobe at this point? 7 joules. And it uses all of them up here. So what's the value here? 0 joules. So what is the voltage used up across that? 7 volts. And what is the total amount of energy that was taken in? And what's the total amount of energy that's given out? So how much was the energy it started off with? 10. And how much is the energy that it gives off? 10, right? Now, a value these values that are right here, they are called potential. And I'll explain soon can it take potential bola hoy. So these are called potentials. So ekhano potential ekta. And this value that we have here, this refers to the difference in the two potential. So upperta koto 10, nicheta koto 7. So what would the potential difference here be? 3, right? So আমরা যখন একটা কম্পোনেন্টের across এ কত ভোল্টেজ থাকে বের করি, what do we find? Potential difference. So potential difference মানে কি? We see the amount of energy that enters, we see the amount of energy that leaves. Wouldn't that be the amount of energy it consumes, right? So যখন একটা voltmeter use করা হয়, and this is very strictly followed in your like A levels, একটা voltmeter কি measure করে? Potential difference, not voltage. Can a voltmeter do the tar thake? And once you do practicals, you'll find there's a red wire and there's a black wire. The black wire is the negative terminal of the voltmeter. The red wire is the positive terminal of the voltmeter. তুমি যখন দুইটা তার নিবা and you place it in your circuit, right? One of the charge enters to the black wire. One of the charge enters to the red wire. ভিতরে একটা circuit থাকে that measures the potential of the black wire, measures the potential of the red wire, and what does it show? The difference. So whenever you measure voltage using a voltmeter, you're not measuring voltage. You're always, every single time measuring what? Potential difference. Do you understand? So তুমি যদি তোমার voltmeter দুইটা terminal একই জায়গায় দাও, what would the value be? 0. Why? Because যেই চার্জটা enter করতেছে দুইটার মধ্যে same energy তে enter করতেছে, so what would the value be? 0, the difference, right? So do you understand what potential difference is? Potential difference is the difference in energy per coulomb charge between 2 points. Okay? What is voltage? The amount of energy transferred per coulomb charge. That's the umbrella term. Okay? Now, একটা জিনিস বাকি, ওইটা হচ্ছে এই যে ভ্যালুটা দেখতেছো 10, right? Isn't that the maximum possible energy provided, right? This one is referred as what of your battery? EMF. So EMF টা কি তাহলে? EMF is the total amount of energy provided per coulomb charge to the circuit. Okay, so EMF is the total potential difference, the difference between any 2 points, right? Our voltage, the generic term that implies both of them. So এখন থেকে জিনিস মনে রেখো, voltage is never going to be the answer to anything. It's either going to be potential difference or what? EMF. বুঝছো? Because voltage is like a umbrella term. It signifies every kind of voltage out there. EMF, potential difference, potential সব কিছু. So তোমরা যদি খালি voltage বলো, it leaves your answer quite vague. It doesn't really make sense. So আমি যদি বলি a component has voltage of 10 volts. আচ্ছা? Can you tell me, is this a battery or a resistor? A component has a voltage of 10 volts, right? Is this a battery or a resistor? We can't say. But if I told you the EMF is 10 volts, is it a battery or a resistor? Yeah, because EMF is something that gives energy to your circuit, right? If I told the potential difference is 4 volts, what is it? Is it a power source or is it a component? Component. What's the difference? So tomorrow the thing is that whenever you have a question, right? Or find voltage. Or find potential difference. Okay. Anyways, some definitions go there to copy going now. So EMF, potential difference, and just voltage as general. There's a page on voltage, I'll tell you. Page 80, either 84 or 82, any one of these places. There are a few papers shown. Not 1 coulomb. So 1 coulomb means 1.8 into 10 to the power 20 electrons. So that many electrons carry 3 joules. যখন দেখে show one object, right? That's basically all those electrons together. That's 1 coulomb. Coulomb is the unit of charge. Charge is a quantity, coulomb is the unit. No. one electron has a charge of how much? 6 into 10 to the power minus 19, right? So 1 coulomb is provided by how many electrons? A lot. 1 divided by 1.6 into 10 to the power minus 19, which is something like, I forgot the number, but power 10 to the power 20 আসে অতগুলো electron মিলে 1 coulomb charge দেয়। Carrier of the charge. Yeah. Done? Okay, so এখান থেকে we'll derive a couple of equations. Again, stuff we have done in O levels, but our correct one, okay? So let's say you have a lamp here, okay? And a lampটার হচ্ছে brightness জানতে যাচ্ছ. So listen carefully, I'll be asking you a few questions. So you have a lamp here, and a lampটার হচ্ছে brightness জানতে চাই আমরা, right? So I have few options for you. I can provide you with the current value, I can provide you with the voltage value, or I can provide you with the energy value. Which one do you think will tell me the brightness of the lamp properly? But I'm usually দুইটা lamp compare করতে চাই, and somebody asks me compare them, and I tell them যে voltage বেশি, তাহলে brightness কি বেশি? Current বেশি, is that what brightness is based on? Or energy বেশি, is that what brightness is based on? Energy. আচ্ছা, okay. So আমাদের formula কি ছিল for voltage? Voltage equals to energy per coulomb charge. So energy equals to voltage into what? Charge. And do you know Q equals to what? We have seen before, IT. So you can take আমাদের electrical energy formula VIT, which you have learned since like grade 9, I think, or maybe 8, right? So electrical energy is what? VIT. That's a derivation of it, right? So if somebody tells me that তোমার হচ্ছে there's a lamp and ওটার brightnessটা কিসের উপর depend করে, and there are 3 quantities that we can use. একটা হচ্ছে energy, electrical energy, আরেকটা হচ্ছে your voltage, আরেকটা হচ্ছে your current, right? Which one do you think would be the better judgment of the brightness? কোনটা? মানে question কি বুঝছো? I'll rephrase it if you don't understand. I have a lamp 20 volts, okay? And I have a lamp 9 volts. Kounta brighter? 220 or 9 volts? Which lamp is brighter? 9 volts. Why? Power. But I said the voltage, right? So okay, so I'll tell you, voltage probably I can use very high voltage, but my charge is just very slow. Like your brightness, if I go again, you have this big bucket, right? But no one wants to walk in the bucket. Does that help? I don't know what tank would go, right? No, right? So you have very high voltage, 2000 volts, right? Current is 0.0000001. So lamp will go with absolutely no, like they what's your voltage? 2000, right? So does voltage help here? No, right? However, you have very high current, right? So run around with empty bucket. Does that help? You're the fastest person with the bucket. What about bucket? Empty bucket, right? So it doesn't help. So bucket will be the empty bucket, which means voltage 9. Does it help? So is current a factor? No. I mean high current making a lamp glow? No. Is voltage a factor? No, because of the beshi energy DC, but no one's walking with the bucket. Does that help? No, right? So eventually what matters? The amount of energy you provide, right? So that's where comes another problem that will keep, right? And I'll get to a point eventually. So I have 2 lamps here. Tell me something, okay? One lamp uses 50 joules. The other lamp uses 10,000 joules. 50 joules and 10,000 joules. Which one is brighter? Why can't you tell?
Because the energy could be needed in 1 minute or
50 volts lamp?
yes.
Achha, 50 and 10,000, right? Which one is brighter? You said you can't tell. Why? Achha, okay. I appreciate that you understood the basic logic behind it. The answer is you can't say, and I'll tell you why. I could have the world's brightest lamp, right? But it only glows for 0.1 second, like 10 joules nibe. Or I could have a lamp that's very dim, but it was running for like 10 years. How much energy did it consume? A billion joules, right? But what lamp was it? A very dim lamp. So you know what the problem is here? The energy, right? Is something that tells you how much energy it consumed over time. But does it tell you how much energy it consumes every second? No, right? So if I finally want to know what the brightness of my lamp would be, right? What should I go for? How much energy it consumes when? Per second, right? And what do we call that? Power. Okay, so power is the final thing. That's why this is something you have to be very careful about whenever you compare any electrical appliance. Just physics and just in your real life. Don't fall for scams. Okay, they will tell you etar current beshi, etar voltage beshi, etar energy eto. What do you always look for? Power. Acha, and mostly, if they're honest, they'll give you the power. So তুমি যদি একটা lamp কিনতে যাও, right? If you want a brighter lamp, what do you go for? Yeah, 100 watt, 10 watt, 5 watt, right? You want to buy, let's say, hair dryer. Hair dryer, দুইটা পাওয়া যায়, একটা 1000 watt, একটা 5000 watt. কোনটাতে would your hair dry faster? 5000, right? I mean, every appliance you buy, they go উপরে হচ্ছে watt দেওয়া থাকে, বড় করে, like that's their advertising, because that's what matters. Clear about that? So how do we get power? So power বের করার জন্য formula হচ্ছে এটা. So electrical energy is equal to what? Electrical energy is equal to VIT. And what's the formula for power? Energy by time, right? So electrical energy divided by time. So if I divide this side by time, I have to divide that side by time, VIT by T. TT cancels out. So therefore, what's the formula for electrical power from grade 8? VI, right? But since we already have done that, tell me the other variations. Aru duita ase. P equals to V square by R, correct? V square by R. Arta? I square R. Okay. O levels se auto important chilo na. O levels se last eta lagto for transformers. A levels se this will be of a very big difference to you. MCQs se. So MCQs the questions are custom designed that তোমাকে কোনটা ইউজ করতে হবে, V square by R. তখন দেখবা যে অন্যগুলো করতে গিয়ে অ্যানসার আসবে. There's nothing wrong in them, but only time consume হবে. And do you know how to derive these? P equals to VI এর মধ্যে I just incorporate what law? Ohm's law. V equals to IR, I equals to V by R. করলেই চলে আসলো. Okay, so কখন ইউজ করতে জাস্ট হিন্ট দিয়ে রাখি, এটা ইউজ করবা in parallel circuits. তোমাদের জাস্ট একটা টিপ দিয়ে রাখলাম। আচ্ছা, parallel circuits this is very useful because parallel circuit কি সেম থাকে? Voltage, so you can easily compare resistance and power here. Our series circuit গুলোতে কি সেম থাকে? Current. So this is very handy there. So I've seen that over the years, এটা যদি মনে রাখতে পারো, it's more beneficial over the long term. Like a student are easily answer বের করতে পারে. So whenever you want to compare two components in series, right, in terms of how much power they give off, what do you use? I square R. What's same through them? Right, and then I just compare their resistance, right? So yeah, these are the equations of power. আমাদের এখানে আর কিছু এরকম নাই. There was this one exercise I had to do with you guys, ওটা আমি করবো in a bit. But তোমাদের কোনো question থাকলে আমাকে বলো, I'll strike these off. Okay, it's your responsibility to let me know যে বুঝো নাই, okay? Because আমি তো O-level এর জিনিস revise করতেছি. The syllabus tells me that you already know these, okay? আমার এটা করার কথা না. So তোমাদের যদি কোনো problem হয় আমাকে বলো, I will go through it again in details, okay? But I want to focus more on stuff that are new. I think that's the more logical thing to do, okay? So বলো এখানে কোথায় problem? Potential difference কি তা approach V equals to W by Q, P equals to VI, I square R, V square bar. দেখো it's a recall and use. Or যখন you recall what they use for in your syllabus, what does it mean? It means that এটা provide করা থাকবে না, এটা তুমি যদি recall করো, what do you get? A mark. আর অনেক জায়গায় equation দিয়ে দেয়, I don't know if you know, অনেক booklet থাকে with pretty much a lot of equations out there. ওগুলা যখন তুমি লেখো এটার কোনো mark নাই, it's already given to you, right? But এগুলা দেওয়া থাকে না, এগুলা যদি just formula লেখো and let's say you can't do the math, you still get a mark, okay? So always look out for these recall values, okay? হ্যাঁ, যাদের ক্লাস আছে you can leave by one. যাদের নাই I'll just do one math. আজকে আপলোড করে দিব ম্যাথটা, যদি না পারো আমরা নেক্সট ক্লাসে আবার চেক করব ম্যাথটা। derivation of this. Did any of your schools start particle physics? Are you done with particle physics? Yesterday. Electricity, like everything else is over, right? তোমাদের একটা জিনিস skip করছিল, yeah, deformation করে নাই? What's the thing with deformation? Like সব বাদ দিয়ে just is it like intentionally left out or they forgot about it? আচ্ছা ঠিক আছে। আর DPS কি খুলছে? Oh, are you done with particle physics? That's okay. And you're done with waves, right? Okay, look at this. You have a circuit provided here, and these are different points on the circuit. What you're going to do right now is take a voltmeter and connect the terminals of the voltmeter across these points. Okay, so let me show you what I mean by that. So voltmeter এরকম থাকে. By the way, just quick review of voltmeters. মানে আমাদের theory জন্য একটু লাগে. We use one of these things. These are called multimeter. Okay, so there's ammeter, voltmeter, and everything here. তোমরা যদি হচ্ছে ল্যাবে করে থাকো, you must know some safety precaution here. Can you tell me which way do you rotate the knob? Anti-clockwise. Let's say if you ever rotate it clockwise, right, in a series setup, it's gone. তোমার ammeter নষ্ট হয়ে যায়. Okay, instantly short circuit হয়ে যায়. So you should never go this way because এখানে আবার একটু designer flaw আছে with the multimeter. If you go clockwise, it starts with the least resistance value out there. মানে সবচেয়ে বেশি current flow হয়ে যায়, and it causes your circuit to like এটার ভিতরে সার্কিটটা নষ্ট হয়ে যায়. And the unfortunate thing is circuit নষ্ট হওয়ার পরও what will it still show? It will show a reading. Okay, and it will show a reading that looks like a very good reading, but it's a what reading? Wrong reading. আচ্ছা, so very unfortunate. এখন এক্সামে যেটা হয় আগে থেকে হেডস আপ দিয়ে রাখি, you might end up having a voltmeter that's already ruined. Okay, so has happened. many times before because somebody before you came and used it সে তো নষ্ট করে চলে গেছে এখন ওই invigilators and examiners and lab যারা থাকে তারা সবগুলো আবার রিচেক করে না so I will tell you a test to do that will allow you to figure out whether it's working or not it's your responsibility I know পরীক্ষাতে you can blame the people who take the exam as much mark বাড়ায় দিবেন না কোনোদিন right so তোমার responsibility to be safe here so always remember that you should go which way yeah anti-clockwise যদি যাও দেখবা 1000 220 200 milli মানে what value do you start from very large and then you go to small so your circuit is always what safe okay আর দেখবা মাঝে মাঝে একটা 1 এর মতন শো করে এই যে এরকম দেখতে this is just one bar একটা এটা মানে কি yeah it means calculator math error show করে না ওরকম মানে এটা যদি শো হয় কোনো সময় right away open the circuit it means overload এর মতো okay so don't use that so আমার যে এটা show করতেছে I'm trying to measure current but the current is too high for my device তখন এটা show করবে it is not what though 1 okay I've seen a lot of students go like আমার answer perfect 1 chilo exam so that's what it's completely wrong okay it has happened luckily in like a school exam but actual exam hopefully not high it is wrong this is just math error show করার the নিয়ম so anyways you have your knob here knob থেকে ঘোরাতে থাকবা and voltage show করবে but the thing is you have certain connections here so তিনটা কানেকশন থাকে তিনটা কানেকশনের মধ্যে কোথায় যেতে হবে এটা একটু বুঝাই দেই so you have your do you know where the black wire should go মানে তোমাদের এটা জাস্ট আমি দেখাই দেবো একটা ব্যাটারি দিয়ে চেক করতে হয় ব্যাটারিটা থাকবে ব্যাটারি ছাড়া হবে না আমি এটা ছবিটা দিচ্ছি তোমাদের as far as I know last time check করছিলাম এটাই এক্সামে দেয় just the black version of this but এই particular মডেলটাই দেয় some schools have like very big yellow version একটা some schools have like a bigger screen নতুন পাওয়া যায় but essentially it's the same thing okay so I'm not really sure এর বাইরে কিছু দেয় নাকি দেয় তোমাদের red and black what is that it's like two-tone voltmeter that's very fancy what is it আমি বলছি ইন্ডাস্ট্রিয়াল যেটা যে এত বড় একটা থাকে it makes a sound না ওটা এডেক্সেল সরি কেমব্রিজ অ্যাফোর্ড করতে পারবে না তোমাদের তো স্কুলে হয় হ্যাঁ তোমাদের স্কুলে হলে তোমাদের স্কুলেরটাই দিবে আচ্ছা ওইটা it looks like that হ্যাঁ যে নিচের দিকে ন্যারো থাকে যে সাউন্ড হয় তারপর যে হোল্ড বাটন আছে হ্যাঁ ব্যাকলাইট আছে like very fancy অন্য কেউ কি এরকম পাও does it have Wi-Fi or anything I've never heard of that but anyways basic function of a voltmeter is universal by the way Chinese ra banak ba Russian ra banak the voltmeters all look the same okay it's a standard out there so don't get to just dekhe rakhi ki hoy so it's like a rubber casing and everything we had one of those before but ওই যে যেটা হয় যে আগে যে কমন এক্সাম গুলো হতো কেউ দিত না so we went for this one so I'll get one of those আচ্ছা anyways তোমাদেরকে একটু because practicals লাগবে দেখে রাখি এই যে these are the three connections that you see and by the way it's a universal whatever voltmeter you guys use এই তিনটা কানেকশন থাকবে এখানে একটা হচ্ছে যে এটা আর একটা হচ্ছে this one and the other one is this one right so how do you connect your voltmeter to measure the voltage across DE for example so এই যে আমার DE যে পার্টটা এখানে আমি ধরো ভোল্টেজ মেজার করতে যাচ্ছি আমার তারগুলো কেমনে কানেক্ট করব so you get these probes red and black right redটা কোথায় যাবে আর blackটা কোথায় যাবে yeah so এই যে তোমাদের সিলেবাসে এইটা লাগবে না this upper version because how much is it 10 ampere DC 10 ampere DC is a very large current এটা কোথা থেকে পাওয়া যায় from the mains okay mains থেকে পেতে পারো or from like a power supply বড় যে power supply থাকে batteries can't provide such big values also batteries যদি provide করেও থাকে এত বড় value right তোমরা এক্সামে দিবে না what's the issue the circuit heats up a lot okay eventually দেখবা যে সব রেজিস্টার থেকে smoke বেরোচ্ছে heats up too much right so আমাদের যেগুলো ইউজ করা হয় যে এই মোডটা ইউজ করা হয় what is that voltage measure করতে পারবা, resistor measure করতে পারবা, আর current measure করতে পারবা in what ampere, মিলি অ্যাম্পিয়ার। তার মানে যে এই সেগমেন্টটা ইউজ করতে পারবা খালি। ওকে, সো এইটার জন্য the red wire goes here, সো এখান থেকে red wireটা বের হবে from this part, and নিচের পার্ট থেকে তোমার হচ্ছে ব্ল্যাক ওয়্যারটা বের হবে। ব্ল্যাক ওয়্যারটা হচ্ছে কম বলা হয়, কমসে যায় এটা। This is the standard. Okay, now what if in the exam you make a mistake, red or black উল্টা করে ফেললা, right? What would be the consequence? Yeah, it'll perfect answer আসবে, কোনো কিছু worry করো না। The only thing is that there'll be a negative sign in front of your value, আচ্ছা, which you ignore. So আর যদি তোমার মনে হয় যে না, just change the wires, that's it, সাথে সাথে আবার প্লাস হয়ে যাবে। Okay, so yeah, once you take your voltmeter, you'll take one of the wires from here যেটা কম থাকে, ওইটাকে নেগেটিভ টার্মিনালের দিকে দিবা। সো এখানে ইটা কি নেগেটিভের দিকে না? If you look at the battery, isn't the E on the negative side, right? And D is on which side? The positive side, right? So এটা করলে তুমি কি ভ্যালু পাবা? একটা positive value পাবা। Now what would this measure if I connect my voltmeter like this? Potential difference, okay? And that's how you find the voltage. So আমি যদি এই তারটাকে নিয়ে এখানে কানেক্ট করি, what would I find now? Between F and D, right? আমি যদি এটাকে এখানে নিয়ে এখানে কানেক্ট করি, what will I get? Yeah, potential difference between G and D. বুঝছো জিনিসটা? What if I take this and connect it here? Yeah, it's at the same place. So what's the potential difference? Zero, right? What if I connect it here? Ki show korbe? 100 volts or zero? Yes. Why? Because amar ki hobe, the charge that you have here, এখানে আসছে, what potential does it have? 100. কারণ কিছু তো ইউজ হয় না এখন। আবার এটা যখন এখানে আসবে, what potential will it have? 100 as well. So what's the difference? Yeah, exactly. Now, can you tell me how can I connect my voltmeter to get the EMF? If I connect it here, wouldn't I get the full voltage of my battery? Cannot, because হচ্ছে যে এখান থেকে যে বের হচ্ছে, wouldn't that give me 100? আর এখানে যখন back because what would that do then? Zero. What would that give me? Yeah, the potential difference across the battery. And what we call the potential difference across the battery. Yeah, that's how you find it. Okay, so yeah, that's how you use this circuit. Anyway, এটা হচ্ছে ম্যাথটা আমরা নেক্সট ক্লাসে করব, because সবাই থাকবে না।